The next speaker is the author of an article entitled Parametrical Analysis of Vacuum Contact Devices for Wall Climbing Robots. The speaker is Maxim Knyazkov. Please.
Okay. Hello, dear colleagues. My name is Maxim Knyazkov, and I working in the Institute for Problems in Mechanics of the Russian Academy of Science. I glad to present a paper, Parametrical Analysis of Vacuum Contact Devices for Wall Climbing Robots. Underwater wall climbing robots are intended for motion along vertical and slope surfaces in extreme underwater conditions, and they supply special vacuum contact devices for satisfy reliable contact between the robot corp and the surfaces. Vacuum contact devices include a generator of vacuum, pressure pump, or ejector, corp with flexible walls contacting with surfaces, seal ring, and pneumatic pressing drive for lift and lowering. It is possible to use several vacuum contact devices on every leg of wall climbing robot. For example, there in this fig A and B, to satisfy its variable motion over surfaces. Under consideration, prototype of underwater wall climbing robot is intended for inspection underwater vertical surfaces. Design diagram of one vacuum contact devices in this fig includes following components. Elastic seal, it's number one. This step burning, this chamber 3, and and vacuum generator 4, pressure drive 5, position sensor 6, and plunger 7. Distance between vacuum contact devices plane and surface is denoted like gap H. The placement of the plunger is denoted like Y. Pressure PS and PA are forming by control system and intended for plunger motion up and down. Vacuum generator 4 is intended for creation absolute pressure P2. Environment pressure PB depends on underwater wall climbing robot depth in water. In the air, PB equally PA. Since it is atmospheric pressure, output channel of vacuum generator is removed from water and connected with environment. The diagram of calculation model in this fig includes chamber with two pneumatic restrictions. One of has constant cross section and connects chamber with vacuum generator, and other of it has variable cross section, that is nozzle flap throttle. Sugar's vacuum contact devices calculation model includes non-linear characteristics of nozzle flap throttle. The following admissions are taken in consideration. Flow is indisably, density is neuralized, friction force is undimensional, load is non-linear of nozzle flap throttle. The goal of parametrical analysis is elucidation of mechanism and of parameters interactions. Designations of parameters are shown in this fig. The links between parameters are delivered at these diagrams on relative coordinates. It is important to know how mass flow depends on pressure for different gaps when vacuum contact devices is under action. The dependence of relative mass from Q1 and Q2 on pressure relation P2 and PB is represented in this fig. where gap value are H4 more than H3 more, H3 more than H2, H2 more H1, and Q1 is the mass flow in output chamber. It is clear that Q1 equally Q2 in the case if P2 equally PB. Pressure difference across the gap then 0 more P2 and smaller 1.0 and PB is constant. Pressure difference P2 and PB across the gap H under various pressure P1. The characteristic of pressure in relative coordinates and functions on gaps are delivered in figure this and this. During which pressure P2 is typically lies in the range between 0.1 and 1.0 for the case when PB is constant. The pressure P1 may be changed like P11 more than P12 and P12 is more P13. Is this nomogram presents generalized relationship between pressure parameters P1, P2, and gap H. The nomogram permits to find pressure values across the gap H for relation value of flow. The motion path cyclogram in this fig show the motion phases and parameters change of vacuum contact devices functioning this drive sending on contact surface. The cyclogram of vacuum contact devices functioning this reverse motion of the pressure drive is presented in this fig. And conclusion. Linearized vacuum contact devices model was designed for wall climbing robot application that can work on atmosphere and underwater environments. Pneumatic chamber of vacuum contact devices is depicted its change volume with variable and constant pneumatic restrictions that were included on input and output of chamber. Parametrical analysis of vacuum contact devices was delivered to calculate links between pressures, flow rates volumes, forces, and study necessary mode of operations. The results of research and development permit to find relationship between working parameters. The motion path cyclogram and pressure changing characteristic illustrate depends of pressure and flow on geometrical sizes on critical gap between end of vacuum contact devices and surfaces along which wall climbing robots move. The presented results of parametrical analysis study can be used to calculate mode of operations, prospective prototypes of vacuum contact devices for equipped wall climbing robots intended to move over vertical, slope, and ceiling surfaces under complex environments. Many thanks for your attention. If you have some question.
Thank you, Professor Knyazkov. Is anyone have any questions?
Okay, many thanks.
Thank you. So we have some time.